Today we are continuing our discussion of factoring, but moving on from GCF and special products to trinomials that take the form x squared plus bx plus c. Now, these, of course, would be trinomials that don't fit that PST pattern, meaning that I either don't have a plus sign here before the constant, or the constant isn't a perfect square, or maybe the middle coefficient is not 2 times the square root of the front times square root of the back. So we're again just talking about ones that do not fit that special PST pattern. So when we go to factor these trinomials, we have to remember, like we talked about in the last lesson, that to factor a number or expression means to write it as a product, that's multiplication, of its factors. So we are going to write these trinomials where everything's separated by either addition or subtraction, and we're going to write it as the product, that means multiply, of two binomials. So these are just some examples of ones that are already factored. So when I look at x squared plus 8x plus 12, its factored form has two binomials. First one x plus 2, and the second one x plus 6. Like what we talked about in the last lesson, all of factoring you should be able to check, because if I go to FOIL this two binomials, x times x for the F, x times 6 for the O, 2 times x for the I, and 2 times 6 for the L, notice like terms in the middle give me 8x, and I'm back to my original. So that's one thing I just really can't say enough, is that you should always be able to check your answers and know if they are correct. So here in B, I had x squared minus 5x plus 6, and this factored into x minus 3 times x minus 2. So notice in my first example, plus, 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 plus. Here I had minus, plus, minus, minus. And then here with x squared minus 7x minus 18, in my factorization I have a minus and a plus. So the first pattern that we want to observe by looking at these ones that are already done is how do the constant terms in the factors relate to the trinomial. So this is a two-part issue. So how do the constants of factors relate to constant of the trinomial? So that question is, how do the 2 and the 6 relate to the 12? So positive 2, positive 6, what's their relationship to 12? And is that the same as the relationship between negative 3, negative 2, and positive 6? Between negative 9, positive 2, and negative 18. So hopefully what you just noticed with me giving you all those numbers is that the constants in the factors multiply to give you the constant of the trinomial. So we're going to say multiply to c, because form x squared plus bx plus c. So the numbers in the factors, all of these multiply to c. So 2 times 6 is 12. Negative 3 times negative 2 is positive 6. Negative 9 times positive 2 is negative 18. So this is true for all of them. The two constants in your factored form multiply to c. Then we also want to know how the constants of the factors relate to the coefficient of the middle term. So meaning, how do those same two numbers relate to the b? So how do 2 and 6 relate to 8 mathematically? How do -3 and -2 relate to -5? And is that the same as how -9 and +2 relate to -7? So look at all those numbers and see, how do these factors relate to my b, to my coefficient in the middle? Hopefully you said that they add to b, because -9 plus 2 is -7. -3 plus -2 is -5. And 2 plus 6 is 8. So this is always going to be true. Then it wants to know, how does the constant term of the trinomial relate to the operations of the binomial factors? So meaning we're talking about the signs now. So when they were both plus, that means we had plus plus. Here, when we had minus minus, that gave us minus plus in that order, because two negatives multiply to a positive number, but they add to a negative number. When I have minus plus, that is going to be the one where it could be either a minus minus, or we don't have an example in this case, but it could be a plus minus. The key is that if your C is negative, we're going to have one with a plus and one with a minus. If your C is positive, they're always going to be the same. So you can look at the B to figure out which it is. So if the C term is positive, it's either minus minus if this is a minus, or plus plus if this is a plus. So the only time we end up with one plus and one minus in the parentheses is when the C is negative. So I like to call these type of trinomials chart factoring, because I think that a chart is a good way to organize your thoughts if you're having trouble. Now, do you have to draw a chart every time if you already know the answer? No, because what we are looking for are factors that do what we have in this first example. We want factors that multiply to the C value and add to B. So we are looking for factors that multiply to C and add to B. So the reason I call it chart factoring is because I draw this nice little chart over here and I actually write it out for the problem. So we want things that multiply to +3. So +3, things that are going to multiply there, and we consider our signs. Since this is a plus and this is a plus, I know that I'm only listing positives. So 1 and 3, that's it, because 3 is prime. So we're hoping that those are going to add to my B, which is 4. And when I look at them, yes, they do. So 1 and 3 are my winners. They do add to 4. So I fill them in. Notice that all of these had X's in front, and then the factors go in the back. Both of these factors were positive, so I do a +1 and a +3. Remember that you can FOIL it back out if you need to check your work. So x + 1 times x + 3 is going to be my answer here. So in this second one, I am now looking for factors that multiply to 12 and add to -7. So things that multiply to 12, and I know because this is a plus and this is a minus, that it has to be minus minus. So I'm looking for two negative things. So -1 and -12. And then I just moved down. So I started with -1, now I'm going to go to -2. -2 and -6 are a set of factors. -3, -4. 4 is already listed, so I've wrapped around, so I know for sure that's all the factors. These add to -13, these add to -8, these add to -7. I wanted to add to -7, so these guys are my winners. So 2 parentheses, x in the front, or whatever variable you happen to be using, and then I need a -3 in one of them, a -4 in the other. And that is my factorization. So one more example here. This time we're looking for numbers that multiply to -15 and add to 2. Now, when it's a minus here, you know that you have to list one with a positive and one with a negative. So -1, +15, or +1, -15. 15 is not divisible by 2, so then I would try 3. So -3 with +5, +3 with -5. It's not divisible by 4. And the next number would be 5, which I've already got listed, so I know I'm done. This adds to 14, -14, 2, -2. So the winners are the ones that add to +2, which would be right here. And then again, x's go in the front, -3 in one of the parentheses, +5 in the other. All right, so we've got a lot of examples here. I want you to go ahead and try the next one. So factoring x² plus 8x plus 15. And so your final answer should be the product of two binomials, just like the 3 examples I just walked you through. So go ahead, work on that problem, pause it while you do, and then come back to check your work. All right, so we were looking in this case for what multiplies to 15 and adds to 8. So things that multiply to 15, 1 and 15, not divisible by 2, 3 and 5. Again, the reason why I'm listing positives here is because of these signs. I had positive, so I knew they were both pluses. These add to 16, these add to 8, so these are my winners. So hopefully you said x plus 3 times x plus 5. Now, I had mentioned earlier that you don't always have to write out the whole chart if you just know the answer. Because sometimes just saying what multiplies to 15 and adds to 8, you know the answer in like the snap of a fingers. And if you do, then you don't need to write all of this out. You can just go ahead and do x plus 3 times x plus 5 and then mentally check your work with a FOIL, just like I showed you in the first example here. You can, in your head, go ahead and FOIL it to make sure that it's right. Now, I will say that if you are having trouble with a factored problem, and you don't have the chart with all the factors written out, then you haven't tried hard enough, because sometimes you just miss a factor. And if you have the chart that lists them all in order, you won't miss one. Okay, so now let's look at another one. So x² minus 5x minus 14. So we are looking for what multiplies to -14, and we want it to add to -5. So we're multiplying to a negative, so that means I need to list one with a plus and one with a minus. So it could be -1 and 14, positive 1, negative 14, and I always just go up by the next number. So I look to see if it's divisible by 2. Yes, 14 is divisible by 2. So negative 2, positive 7, positive 2, negative 7. Then I look, is it divisible by 3? No, it's not. Is it divisible by 4? No. Divisible by 5? No. Divisible by 6? No. The next number would be 7, and because I've come back around to what's already listed, I know I've got them all. So I look to see what they add to, and I wanted the ones that add to negative 5, so that would be this guy right here. So x plus 2 times x minus 7 would be my factorization. All right, so now looking at C, we're looking for what multiplies to 3 and adds to negative 5. So positive C with a negative B. So that is the situation where we have, minus minus here. So that means both the factors I list have to be negatives, like in this example up here. So that'd be negative 1, negative 3, and 3 is prime, and I can't list any positives, so that's the only possibility. And when I add those, I get negative 4. So this would be an example where this trinomial is not factorable. So it says if they're not factorable, we're going to write prime. Now again, before you write prime, you better check your chart. You better make sure that the number you've listed here doesn't have any additional factors. And you can just go through with your calculator, 3 divided by 2, and double check to make sure. But in this case, we know there are no other factors of 3 that are going to give me a negative here. And it doesn't add to the right thing, so that makes this one prime. All right, I want you to go ahead and do D again on your own. So make your list. We're looking for what multiplies to 48 and adds to negative 16. So multiply to positive 48, add to negative 16. So go ahead, pause it, make your list, find your factors, and then unpause to check. All right, so we know because this is a positive C with a negative B to multiply to a positive number and add to a negative, that means they both have to be negatives. So this is a bigger number, so it's going to be a bigger list. We've got negative 1 and negative 48. Then I say to myself, is 48 divisible by 2? Yes, it is. 2 and 24. So list those guys. Then I ask myself, is it divisible by 3? And if you don't know, then check it. Pull out your calculator and double check. So in this case, it is 3 and 16 gives us 48. Then is it divisible by 4? Yes. 4 with 12. Is it divisible by 5? No, because it doesn't end in a 5 or a 0. Is it divisible by 6? Yes. 6 and 8. And so then the last one I need to check is 7, which 48 is not evenly divisible by 7. And I'm back around to my next number, so I know that this is the entirety of the list of my factors. So now I look, what do they add to? Negative 49, negative 26, negative 19, negative 16, negative 14. So I was looking for the ones that added to negative 16. So these are my winners. So x minus 4, x minus 12. And again, as I said earlier, the order is not important. So if you did x minus 12 times x minus 4, that's the same thing, okay? You don't have to, change your answer or anything. All right, E, This one's here because we want to point out that the format that we are factoring in, x squared plus bx plus c, it's in standard form. This one is not in standard form, so you need to rewrite it first. So x squared plus 10x plus 24. And so now we can see, now that we've written it the right way, that we're looking for what multiplies to 24 and adds to 10. So since they're both pluses, we know I've got plus plus. So 1 and 24, 2 and 12, 3, 8, 4, 6, not divisible by 5, and so I've got them all. So that adds to 25, this adds to 14, this adds to 11, this adds to 10, which is my winner. So x plus 4, x plus 6. Boom. All right, last one, x squared minus 36. So hopefully you are not tricked here. This is not a trinomial. This type of factoring, this chart factoring, this what multiplies to b and adds to c factoring, whatever we want to call it, x squared plus bx plus c, this is not in the right form. So we have to look back and see, well, does this factor with any of the ways that I've previously learned? So is there a GCF? No, because there's no number here and there's no x here. Could it be one of my special products? So the special products are my difference of squares and my perfect square trinomial. This guy is a binomial. So if it's not a difference of squares, then there's nothing I can do. So I'm going to check for difference of squares. If you need to look back at your activity 26 notes, you can pull those out. But what I'm looking for difference of squares is, do I have a perfect square root on both terms? Well, square root x squared is x, square root of 36 is 6. And is it a minus in the middle? Yes, it is. So that means 2 parentheses, x in the fronts, 6 in the backs, 1 parenthesis gets a plus, and one of them gets a minus. And so this is our difference of squares example. It's not in this format, so do not use the chart on that type. All right, that wraps us up here for this one. Make sure that you reach out if you need some clarification.